what happened in the future of the universe.
Mysteries of the universe.
Today we're going to discuss future of our universe. What happens to the future of our universe? Is it eternal, or from the latest observations we know that 73% of the total budget of the universe is occupied by so-called dark energy. And what happens to the future of this dark energy dominated universe? Universe is currently expanding because of this dark energy, because dark energy is repulsive force. It's the opposite of the gravity. It pushes things away. So universe is getting bigger and bigger and bigger, and this expansion of the universe is even accelerating. So the expansion speed is getting faster and faster and faster. That's what we know now. And what happens if universe keeps expanding? The first, in 5.4 billion years from now, the sun's gonna end its life. So the sun is G-type star, and the sun finished burning hydrogen inside, and then sun's helium is going to ignite. Then sun's temperature is going to go up, and then sun's going to become a red giant. And when the sun becomes red giant, because of the increased temperature, sun's going to get bigger and bigger. So the orbit of the Mars is included inside the sun. So at that time, Earth is also inside. So that's the end of the Earth. At that point, Earth is going to be inhabitable, unfortunately. Around the same time, you know that Andromeda Galaxy, our neighbor spiral galaxy here, is actually now approaching to our Milky Way Galaxy at a speed of 770 kilometers per second. That's amazing speed. 4 or 5 billion years from now, our galaxy and Andromeda Galaxy are going to collide and eventually merge into one big galaxy. If you're alive for 4 gigayears, then you will see a spectacular show in the night sky. This small Andromeda Galaxy is going to get closer, 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 and then start merging with our Milky Way Galaxy. At that time, due to the merging shock, there's a lot of new stars going to born in both of these galaxies. And eventually, these two galaxies merge into one big elliptical galaxy, which is very visible in the night sky at that time. So this is a simulation of two galaxies merging. So this is a simulation of two galaxies merging. So one galaxy is like a Milky Way Galaxy, and the Andromeda Galaxy is our neighbor, is approaching to us. Here's Andromeda Galaxy, they are approaching. This is about 3 gigayears from now. And then they're going to have a first collision. About 4 billion years from now, they have the first collision. And after another 1 billion years, about 5 gigayears from now, they have the second collision, and then eventually they merge into one elliptical galaxy. Okay. Next, what happens is about 100 billion years from now, local group galaxies will merge into one large galaxy. It is known that our galaxy and also Milky Way Galaxy belong to this local group of galaxies. And those galaxies are gravitationally bound to each other. So after 100 billion years of long time, they're gonna merge into one large, they're gonna attract together by the gravity, and they merge into one big galaxy, just like Andromeda and Milky Way galaxies merged into one. Next, in 150 billion years from now, all galaxies outside of our local supercluster will pass behind the cosmological horizon, and these galaxies will never be able to be seen. So our galaxy and Andromeda Galaxy, I said, are in local group, and this local group is part of the local supercluster, which is bigger structure, including Virgo cluster and other clusters. And then galaxies in this local supercluster, they're still pulling each other by the gravity, so they remain within a contact. But galaxies outside of this local supercluster, they are not bound by the galaxy. So with the rapid expansion of the universe, those galaxies fly away from us, and they fly away so fast, so they're going outside of so-called cosmological horizon. And once they pass this cosmological horizon, we are no longer able to see those galaxies, because the light behind the cosmological horizon will never reach the Earth. Because beyond the cosmological horizon, even the light cannot beat the expansion of the universe to reach the Earth. After this, we never know there are galaxies outside of our neighborhood. In 100 trillion years, it's called degenerate era. At this time, star formation is going to end. All the stars finish burning hydrogen, stop emitting the light. And then stars, after they die, they become degenerate objects such as white dwarfs, or neutron stars, or black holes. All the hydrogen in stars are burnt, so there will be no nuclear fusion anymore. So because there are no stars, the universe will be extremely dark at this time. So this is called degenerate era. And after 1 quadrillion years, about 10 to the 15 years from now, even planets are flung from orbits by a close encounter with another star. For example, in our solar system, those planets like the Earth, Jupiter, Mars are going around the sun because they are bound by the gravity of the sun. But after this 1 quadrillion years of long time, there will be another star flying by the sun. And then this, because of gravity of this another flying by star, those planets are kicked out of the orbit of the solar system. So all this solar system and the planet system is going to be destroyed by the encounter with another star. This encounter rarely happens, but in 1 quadrillion years of long time, this is going to happen once. After the 10 quintillion years, or 10 to the 19th years, now the galaxies, so the stars are in galaxy, right? And those stars are also rotating around the galaxies. But 90% of those stars are flung out of the galaxies. Because of the same reason, those galaxies will encounter with another galaxy, and because of gravitational interaction, those stars are going to be kicked out of galaxies. And stars in the galaxies are also kicked away because of the similar dynamical interaction happen to the planet. And remaining 10% of the stars gonna fall into the central supermassive black hole. Our Milky Way Galaxy also has a central supermassive black hole, so our sun might fall into this supermassive black hole. And now 1 decillion years, or 10 to the 34 years from now, nucleons like protons, neutrons start to decay. Because nucleons decay, planets are made of nucleon, so planets will even decay and radiating energy. Effectively, all baryonic matter will have been changed into photons, neutrons, and electrons. Now, 10 duodecillion years, 10 to the 40 years, is called black hole era. And at this time, black hole will dominate the universe. The only thing you can find in the universe is almost black hole. But even black holes will also evaporate via Hawking radiation, very, very slowly. Small black hole with 1 solar mass will vanish in 10 to the 66 years. And supermassive black holes, such as the one in the center of our Milky Way Galaxy, will evaporate in 10 to the 100 years. Even black hole era is going to end eventually. And after that, 10 to the 100 years or 1 googol years, this googol is the unit that google.com is named after. This is called dark era and a photon age. Even the most massive black hole will evaporate at this time, and the universe will be nearly empty. Photons, neutrinos, electrons, some of them are still left, but hardly encounter because universe is expanded and so large. So this is the fate of our universe in a very distant future. So are we lucky to be in the current universe? If you think about, at least now we can observe other galaxies. The light from other galaxies to reach, so we can do astronomy. We know there are dark matter, dark energy, and we can investigate them. If you are born after that galaxies outside of local supercluster close the cosmological horizon, then we no longer be able to observe them, so we will never know these galaxies exist because the light from those galaxies never reached the Earth. And even after the dark age, when the universe is empty, we cannot observe anything. There's no star, no planets, not even nucleons there. And then photons, electrons, neutrinos are there, but they are too rare to observe. So there's nothing to do science about. So in that sense, I feel maybe we're lucky to live in the current era when we can still observe galaxies and do science. But the future of our universe all depends on the amount of dark energy. This future prediction is based on the fact that 73% of total energy of the universe is dark energy. That we know from the observation. Then future prediction of the universe depends this amount of dark energy. If dark energy is too little, gravity is going to win and the universe is going to go into big crunch. If dark energy is even more larger, then the universe is going to expand even more rapidly. So it is very important to investigate how much dark energy is out there in our universe. And then also, what is this dark energy? That's what we are trying very hard at the moment. Okay, that's all today. Do you have any questions, comments, thoughts? Welcome at the bottom. If you like the video, please subscribe and also hit the bell. Okay, that's it for today. See you next time.